All right, functions. We just got a little bit finish up with circular motion. This isn't going to take long. This is short. This will be a short one, and then a short assignment. All right, so we talked about circular motion already. There's two parts. There's two kinds. You're either finding the linear speed, which is the speed at which an object follows a circular path. So that involves the arc length and a time. Or you're finding an angular speed, which measures how fast the angle changes. Okay, so it's the angle over time. So again, linear speed is the distance, or in this case, for a circular motion, the arc length over time, and angular speed is the angle over time, usually like revolutions per minute. Okay. All right, so today we're going to use angular speed to find linear speed. The angular speed formula was omega, was the angular thing, just a curvy W. It was theta, the angle, over time. And then the linear speed was V, and that was the arc length over time. So the arc length, how far did it go, divided by some unit of time, or the angle, how many rotations did it make over some unit of time. All right, so using angular speed to find linear speed. So all these formulas aren't anything new, okay? But we're going to use some substitutions to kind of rearrange the formulas. Okay? So the linear speed, V of an object, can also be found using the following substitutions. Well, we just said that V was equal to the arc length S over T. Okay. Now, if you remember from Trig Part 2, the arc length had its own formula. The arc length was equal to the radius times theta, and then you still have the over time. Okay. So all we did was convert the arc length to the arc length formula. Now if we pull out that R value, okay, and it's R times theta over time, those are all multiplication and divisions, so the order of operations, the order of that doesn't matter. So you could rewrite that as R times theta over time. Okay. Well, theta over time, theta over t, is the angular speed. So we could substitute that in and rewrite our linear velocity, our linear speed formula, as the radius times the angular speed, or R times omega. So this is the formula we're going to be using. And all it really is, we're just combining the two formulas, almost like a composition. Okay. So therefore you can use the angular speed omega to find the linear speed V. All right, and then just one example of doing a problem like that. A ceiling fan with 25-inch blades. So I got a picture of my ceiling fan here. Each blade is 25 inches. That means it has a radius of 25. So that's our R. Rotates at 40 RPM, 40 revolutions per minute. What that means is that this point on this blade goes around the circle 40 times in 1 minute. So each time it goes around the circle, it goes a certain distance. Okay, and we're going to have to find that certain distance times 40. And then we're going to figure out in that single minute span, how fast is it going? So what's its distance divided by time? All right, so and then the problem, find the linear speed of the tips of the blades in feet per second. So this is important because it's asking for feet per second, but we have inches, and then RPM is per minute. Okay, so we're going to have to do some conversions at the end. But for right now, let's just figure out the angular speed and then the linear speed. All right, so we'll start with the angular speed, omega. We know it's going around the circle. Each blade is going around 40 times in 1 minute. Okay. Now again, all the way around a circle in radians is 2 pi. So it's going 2 pi angles in one rotation, and it's making 40 rotations. All right. And it's in rotations per minute. Again, the M in RPM is revolutions per minute. So this is going to be 80 pi radians per minute. Alright, so now that we know what the angular speed is, and we also know what the radius is, we can use the new version of our formula, which is radius times angular speed, to find v, the linear speed. So again, since v, our rearranged formula is r times omega, we know what r is. R is 25. And we know what omega is. We just found it. It's 80 pi. So 25 times 80 pi is 2,000 pi. Okay. Now our units for that, our radius was in inches. And then our angular speed was per minute. Okay, now again, radians technically isn't a unit. So this is just inches per minute. We don't want inches per minute. We want feet per second. All right, so we're going to have to convert this. All right, so right now we have 2,000 pi inches. We'll get rid of that pi in a second. Per minute, so per 1 minute. All right. And we want feet per second. So we're going to have to go inches into feet and then minutes into seconds. All right, inches into feet first. We'll multiply. We know, well, how many inches are there in a feet? In a foot. Okay. There's 12 inches per 1 foot. Okay. Since inches is on top, inches has to be on the bottom here. Okay. So 12 inches is 1 foot. Okay. What that's going to do is it's going to cross out inches and inches. So now we're in feet per minute, but we need feet per second. So we're going to have to do one more. We're going to have to convert minutes into seconds. Okay. Since minutes is on the bottom there, we're going to put minutes on top. Put seconds on the bottom. So how do minutes relate to seconds? Well, if you know about clocks, we know there's 60 seconds in 1 minute. And once again, the minutes on the bottom here crosses out the minutes on top there. And we're left with the units of feet over seconds, or feet per second. And then just toss this into the calculator. 2,000 pi divided by 60 times 12 is 720. Okay, so we got 720. All right, so 2,000 pi feet over 720 seconds. We want to make that a unit rate, so we want to divide 2,000 pi. And at this point, I'm going to multiply by 3.14. Because you don't want pi in your final answer. So 2,000 times 3.14 divided by 720. Make sure you could get this in your calculator. 8.7 feet per second. All right, so that's just combining the formulas that we already know. Combine the angular speed, linear speed, and the arc length formula to kind of rearrange our linear speed formula. Okay. So for all these problems, find the angular speed, multiply that by the radius. That gives you your linear speed, and then make sure you're in the correct units. So do the conversion if you have to. All right, so check Google Classrooms for that. Have a great day.